Hello and welcome. This is a follow-up to the last video. If you haven't seen that one yet, you should definitely watch it first since we will build on it. In the last video, we used a grayscale image to size a grid of Blender objects to create a halftone effect. Some people asked, and what about color? And that's what we will do right now. So here is a file that I created before. First, I want to clean up some things. Like, for example, I take that entire tree and delete hierarchy, all of that stuff that was created by animation nodes. And that takes a few seconds because it's a whole lot of objects. Right, also I'm going to get rid of the camera empty, which I created for the animation. Okay, so we still have our dot that we can enable here, this thing, and then we have the grid with the displacement on it. And actually, I'm going to delete the grid as well and create a new one. Okay, there's a few things that we have to think about. So the first thing we want is we somehow have to get the colors into animation nodes, because if we want to reuse that effect that we can plug in an image sequence, we need to animate all of these pins and change the colors for each frame. So the first idea that I had was to actually vertex paint the image onto the grid object. But of course, then you would have to paint that on for each frame somehow, and I don't know, that just didn't work out. Also, I tried to get the data from the vertex colors out of that object, which would work, but then you can't really do anything with that output here. I believe that this might also be a bug in animation nodes. So I came up with a different solution. I don't know if this is the easiest way to do this, and if there's an easier way, then please let me know. But this is what I did. Let me just start by creating another grid. Go in here and create a 50 by 50 grid. Okay, so when I go into object, into edit mode, we have this 50 by 50 grid. Let's go over to UV editing. Now let's load the image that we're going to use, and this is going to be this one, the square color one. I hit U and project from view to get this UV map onto our color image. Okay, so we have a grid and we have a UV map on it. Now, how do we get the color information from the image into animation nodes? And the thing that I came up with was basically the same thing that we did last time with the grayscale values, where we used the grayscale, the brightness, to move each of these vertices on the z-axis, up and down according to the grayscale. So it was all the way down for black and all the way up for white. And for the color, I'm going to use the same idea, but I'm actually going to use the X, Y, and Z coordinate of each of these vertices to be the R, G, and B values of the image. And then in animation nodes, we can take the location information, the X, Y, and Z, and turn it into a color. Okay, so how do we do that? First, we're going to need a modifier, a displace modifier, just like last time. And we create a new texture. Go to the textures tab and plug in this square color image here. And like I said before, we have to take the red, green, and blue values. And we can actually do that very easily inside of Blender. I'm going to call this texture red. And I take the green and the blue down to 0. So now we just have the red channel of this image. And on our modifier over here, we take the red, turn the mid-level to 0 and the strength to 1. We want the UV map for the mapping of the texture. And we want the direction to be X. So we have the red information of the image in the X value of each of these vertices. And now we just repeat that. Displace, I call this red, and we call this one green. We take a new texture, call it green, edit it. This is this same image, but now we turn the red to 0 and the green to 1. Go to the modifier, use UV, mid-level 0, strength 1, direction. Now the green is going to be Y. And another one, displace, new texture, blue, call the modifier blue. Okay. Turn the green to 0, the blue to 1. And on the modifier, we store the blue information in the C value, and we use the UV texture coordinates. Okay, now we have this sort of weird looking thing, Picasso-like face, and each vertex is moved on the X, the Y, and the C for the red, green, and blue information. Okay, now let me call this grid RGB. Place it into this collection, and then we're going to go into animation nodes and use this grid just like we did before. So how can we set the color of an object? Well, first of all, we have to go to the dot object, this little thing here, and create a new vertex color slot, which is always called col by default. And then to duplicate this dot, we also have to enable dip copy so that we get the vertex color slot on each of the instanced dots. Okay, so this is done. Now we can assign a color inside of our loop here. We can search for set vertex color. There's a node, and each dot inside of our loop is this object here. So this is one dot, and we can set a vertex color for this color slot col. Where do we get the color from? Well, over here we already separate the location into X, Y, and Z. And the X, Y, and Z is going to be the red, green, and blue. So we go to color, combine color. X is red, Y is green, whoops, Y is green, and Z is blue. Okay. And this we plug into the set vertex color output. So now each of the pins that we're going to create with animation nodes is going to have a vertex color of the pixel that is in our color image. Now let me change a few things around here. First of all, this is going to be our RGB information. And I'm going to move that down. And up here, we have to plug the RGB grid using the modifiers, because that has the displacements in it. We rip it apart into its vertices and plug that into the RGB. That's all we need to do. How many dots do we want? Well, same as last time, same amount as on this grid. I'm going to save the file and execute the node tree and see what we get. And what we get is this. So basically that same weird thing that we saw before on the grid, on the RGB object, because now everything of course is moved on the X, the Y, and the Z. So this is not really what we're looking for. We want to have a clean looking grid. So now we can't really use this RGB grid to place all the pins on a grid. We need a separate grid. And we can do that by going to generate grid mesh. Okay, so we're not using our Blender RGB grid here. We're just going to create a new one inside of Blender. Inside of animation nodes. So we need 50 by 50 divisions, just like the grid that we did for the RGB stuff. And we'll just make it 2 by 2. We need a mesh info node. Plug that in here. So this gives us a new grid. I'm gonna move this up here and actually use these vertices, although it doesn't matter. It's just the same amount of dots that we want. And now we need to plug this grid also into our loop. So on the loop input here, we need a new input of a vector list. Call that grid. So now we could plug the vertices into this grid. So this gives us the locations. These are the dots that we're gonna instance, or that we instance here. And this gives us the color. Okay, the grid information is where we have to place the dots. So instead of using this vector, we use this vector for placement. Execute node tree. Now we have a clean, nice grid of dots. Of course, we're missing the color because, let's go over to shading. This is our grid of dots. And the dot has a material on it, this black principled shader. We can use an input vertex color col and use that color. And we already get something here. Okay, just a quick recap. How are we getting this color information over here now? So we take the X, Y, and Z, turn it into a color, red, green, and blue, and plug that into the vertex color slot that each of these 2500 dots here has. Each one has a vertex color slot. And each one gets a new color inside of this loop based on the X, Y, and Z values. And now this vertex color slot has, for example, the skin tone color. The one of those dots is maybe on the forehead, and the color here is set to the skin tone. And on the shader side, we use that vertex color slot that we change in animation nodes to set it onto our principled shader. I'm going to turn down metallic and maybe also the specularity. And so we can see that we're already getting something from our animation node setup. But we don't get the real colors. We get sort of a shading, but we also get this red, orange, green, blue thing here. Now, what is the reason for that? Well, that's actually quite easy to explain. Let me hide all those pins and show the RGB mesh and go into edit mode. Each one of those vertices now has or when we look at it this way, has an X, a Y, and a Z for the R, G, and B. But this modifier here just moves the vertex on the X, Y, and Z, but the vertex here still has this base location, this starting point, and this starting point is not 0, right? So this point here is actually at location 1 meter and -1 meter. And that X and Y value here, in addition to the modifiers red, green, and blue, gives us a weird color. And to fix that, we would actually have to subtract 1 and -1 from this vertex, and then whatever this vertex has, we would have to subtract its original starting point location, and so on and so forth. But there's actually a really easy way to get around this. I select all of the vertices, hit S, 0. So I scaled the entire grid down to one single point at 0, 0, 0. And now what the modifiers do is they move all those vertices out into whatever the RGB values are. Now this looks strange, but don't forget that this is still a grid and it still has this UV map on it. Okay, so now I hide this again, I execute my node tree again and enable this collection here. And what do we get now? We get colors. Cool. Okay, so when we look at it from top view, we also notice that it's rotated 90 degrees. Now let's fix that first of all. It's a little bit hard to see because the dots are kind of small. So maybe let's fix something else first. Let's fix the colors and the brightness first. So down here in animation nodes, we have X, Y, and Z. I'm actually going to plug in a loop viewer here for, maybe for the RGB, the total vector. Okay, put that loop viewer over here and then execute this loop. And here we can see the RGB values that we get from our modifiers. But we notice that since we took the green and the blue out to get the red information, on a white dot, all we end up is with 0.33, so with just a third of the entire dynamic range. So first thing we do is we add a number, math, multiply by 3 for the X, and this is our red value. And duplicate this for the Y, for the green value, and duplicate it once more for the C, for the blue value. Okay. So now instead of 0.33, we're going to have values between 0 and 1. And that should give us the correct brighter colors for each of those dots. I'm going to execute this. And here we go. Now these are the correct colors. Now let's turn this grid around. We can do this inside of animation nodes very easily. We take a matrix compose for rotation on the Z-axis minus 90 degrees maybe, I don't know. And then we have to transform all of our vectors here with this rotation and use those vectors for the grid. Clean this up a little. Okay, execute again. Whoops, that was the wrong way. So we turn them 90 degrees, execute. And here we have the image. Okay, now all that's left to do is scale the dots like in the last video, because we don't want all of them the same size. We want this halftone effect. And how do we do that? Well, again, we're going to use the X, Y, and Z information here to plug into our object transform scale right here. So how do we get the overall brightness? Well, we just add up X, Y, and Z. Number, math, add the X and the Y. No, this is not right. We add the X and the Y. And we add to that the C And this is our brightness value to scale the pins. Let's see what that looks like. Okay, this is our halftone effect. Now I noticed that the dark pins are very small. They could be a lot bigger. We again use our map range node that we already introduced in the last video. Maybe even bigger, 1.2. So we get a nice dark area here. And then the bright colors are kind of tiny too. I'm going to make them at least 0.3 big. Okay, so that's what that looks like. And then we notice that we get all those white pins on the outside here that are kind of hard to see. Maybe if I make the world a different color. Oh, I don't have any lights in my scene, that's why the pins are the same color as the background. Lamp point. Just put a point lamp here so we can see those white pins. Now if we want to get rid of all those outside white pins, we can do something in here. Now I'm kind of running out of space here. We can do an if-then statement. Boolean compare. So if this value here is smaller than, let's say, 0.35. Okay, so the smallest value from this map range here is going to be 0.3. And everything smaller than 0.35, we want to change to 0. So if it's smaller than 0.3, then 0. If it's not smaller than 0.35, then we take the actual value and plug that in here. Okay, so this is an if-then, sort of like a threshold. And I'm going to execute the node tree, and then all those white points are gone. And that's it. Now, just like in the last video, you can play with the Z-axis, that is currently 0 here. You can move it up and down or animate it or use the brightness information, this one here, for the C, just like in the last video, or whatever you can come up with, and you can create a camera and animate that and rotate and fly around and whatever you can think of. That's all for this video. I love to read your comments, so please scribble something below. Don't forget to like and subscribe. And I will see you next time.